Hey guys, this week we're going to be talking about something called scatter plots. What's going to be really nice about your notes this week is that they are also in a PowerPoint presentation, just like what I'm showing you. So you have an exact copy of this that you can take your notes in. So no paper, you can type everything in. Hopefully you're watching the video on your phone and have this up on your computer so you can easily fill it in. That'll make life a lot easier. And if you guys like it, then I'll continue doing our weekly notes in this kind of format. Alright, so let's take a look at our vocabulary. What you may need to do is pause and write these down. That'll probably be the easiest way. So our vocabulary, we have bivariate data, and that prefix bi means two. So bivariate data is data for two variables that can be compared to find relationships and trends. A scatter plot is a graph of plotted points that show the relationship between two sets of data. The independent variable, which is something we've actually already talked about before, is usually our x value. It's the variable that is not influenced by outside factors, such as time, days, age. Dependent variables, which is usually our y variable, is the variable that is controlled by an outside factor, the independent variable. And those are also terms that you've heard in science class as well. Alright, so if you need to pause the video, then do that now to make sure you can get those copied down. Why use a scatter plot? Well, using a scatter plot helps us to show a trend of outcomes, to show a relationship between data, and to make predictions. Making a scatter plot, when we have to identify our independent and dependent variables, you have to make sure you label your axes, make your ordered pairs, maybe through a table, plot your points, do not connect the dots. That's a big one. Do not connect those dots. I'm going to highlight that one in red because it's so important. Okay? Do not connect the dots in a scatter plot. And then we usually need to determine the relationship from the graph. Alright, so let's go ahead and make a scatter plot. So here we have this. So we have this set of data, right? And this actually has three columns. The first column is just kind of giving us the categories. The second two columns are actual data points. So the first one is always going to be your x, the second one is always your y. So x, remember, is our independent values, our variable, and y is our dependent. Alright, so the first thing, if we were to flip back to here, is identify our dependent and independent variables. Alright, well, we just did that. Next, we need to label our axes. So let's come over here and do that. So our x-axis is our horizontal axis, remember that? So you have this little text box down here, so I just want you to click in there, double click. It should hopefully be centered, but if not, you can come up here and make it centered. So our x-axis is going to be labeled as fat grams per serving. And then our y-axis is going to be labeled calories per serving. And it's already going to be set up, turned for you, so it should, again, hopefully be centered already. Alright, so we labeled our axes. Now we need to put in a number line going across. Alright, what you're going to notice, if you click really close, like up in those very first row of boxes just below the x-axis, another text box pops up. So I put one in there for you. What we need to do is determine how are we going to number our x-axis. Our smallest value in the x column is 2. Our biggest value is 18. Well, it looks like this goes up to about 20. So let's just count. We can count by ones. So at this point, the very first number you type should line up just about with that first line. And so number with me. So I have 1, I'm going to go 2 times with spaces. I think the next one you got to do 3 spaces. Maybe 2, which we're going to try our best here. You might need 3 spaces before the 5, it looks like. 2 spaces, then the 6. 2 spaces, 7. Maybe 3 spaces, 8. 2 spaces 9, 2 spaces 10, 1 space 11, 1 space 12, and we're starting to get a little bit off here. So make adjustments as needed, um, just to get it all to fit on there. So 13, you might actually not even be able to put a whole lot of space between some of these. 14, so we're just going to kind of do the best that we can. 15, 16, 17, 18, and 19 won't fit. So we just really need to go up to 18. So we've got that one done. I know our numbers are kind of close together in some spots, but we're just doing the best we can to get that number line labeled. All right, so now I can click over here and another text box will pop up. All right, so if I double click, I should have a cursor pop up all the way up at the top. So we are going to start labeling from the top and then go down. So here I need to label from 70 is my lowest up to 410. So we're gonna have to figure out how we're gonna label. I believe I have these set to label for every 25. So if I go 1, 2, 3, 4 is 100, 1, 2, 3, 4 is 2, 1, 2, 3, 4 is 3, 1, 2, 3, 4 is 4, 25, 50, 70. Okay, so we should be able to start at 475, hit enter, and then I think each time we hit enter, we should be able to land right on the line. So then I have 450, 425, 400, 375, 350, 325, 300, 275, 250, 225, 200, 175, 150, 125, 100, 75, 50, and 25. Okay, so now that we've got those labeled, label them the best that you can. I tried to make it as good as I possibly could for especially the x-axis. The y-axis should work out pretty well for us with the labeling. All right, now we need to plot our points. So our first point here is 13 and 306. But we're going to have to do a little bit of guesstimating in here sometimes. Now you should all have this little black dot right here. So that's going to be one of our points that we can graph with. All right, so I can move that all around wherever I want to, but the problem is I only have one of them right now. So what I really want to do is I'm going to right click on it. I should get this little menu here. And I'm going to copy, and then I'm going to right click again and paste. So now I got a new one. All right, so now I'm going to take that one of those dots and I'm going to graph it at 13 and 306. So 13 is pretty easy, that's this line. 306 is going to be up here right around that 300 mark. So we're going to do the best that we can to get that. So 13, and we'll try and get as close to 306 as we can. So let's see. Alright, so I might bump that left a little, oh, maybe not that far left, up, let's see where that landed me. Nope, I think it's going to have to go down. So it's not going to be perfect, we're going to get it as close as we can. So that's about the best that we can do. So now I'm going to click on this, and instead of doing the right click, I can also do hold control down C, and then control V, and that'll paste it again. Alright, so now I can do 13 and 200. So now I'm going to take this and 13, and I need to get it up to 200. So that was right about there. Right, so there's my 13 at 200. Now I'm going to do Control V to paste again, and then I'll just keep pasting. I don't have to copy over and over again, so I already have it. Now I need to do 3 and 150. So that's going to be right about there. Alright, so I got 3 and 150. I'm going to do Control V again. Right, and now I've got 13 and 230. 13 and 230. Alright, well that's going to be right around that 225. Maybe like I don't know if I can get much higher than that. I don't think I really can. So we're just going to kind of put it there. As close as we can. Alright, I'm going to do Control V again to get another dot. So now I need to do 6 and 140. So 140 is going to be just below that 150 mark. And again, these are not going to be perfect, so I'm going to try and bump that down just a little bit. Alright, and let's see if I can bump it over to the right just a tiny bit. And that might be too much. Alright, so close enough. Alright, I'm going to do Control V again to get another point. Alright, now I need to do 5 and 130. Alright, so we just did 140, so this one's supposed to be below that one. I don't know if I'm going to really be able to get it completely. Maybe I can a little bit. Alright, let's see how that went. So somewhere right in there. 2 and 70, so I'll do another Control V. So 2 and 70. So that's going to be almost at that 75 mark. Alright. And then I got one more, so I can just use my final dot, which was 18 and 410. So that's going to be way up here, just above my 400. Oh, where'd it go? I lost it. Oh, that disappeared. Let's try that again. I'll just do another Control V. Alright, let's try that one again. 18 and 410, so just over the 400 mark. Alright, there we go. Alright, so now we've got our scatter plot. We made one. Okay. I know this wasn't perfect. Our points aren't in the exact spots that we want them, but they're as close as we're going to be able to do it on here. Alright, let's go to our next slide. Relationships of scatter plots. So we can classify them in 3 different ways. This first one here, okay, with the green dots, we're going to double click in here. It has what we call a positive trend. This one here is a negative trend. And you might remember those words from when we did slope. Positive slope, negative slope. If this were a single line, this would be a positive line. And if this were a single line, it would be a negative line. Then we got this one over here. The dots are all over the place. So when we see that, we can say that there's no trend or no relationship. I tend to use the word trend. Other people tend to use the word relationship. So they go hand in hand. And I think it just kind of depends on who's talking. Alright, so that was pretty easy. Let's go to our next one. So now let's take a look at this. So example 2. The scatter plot shows the relationship between Marvin's age and the time it took him to run a mile. So let's take a look at what's happening. So as he got older, what happened to the time that it took him to run? So when he was, looks like maybe 11 years old, it took him 7 minutes to run a mile. But then when he was about 17 years old, it took him just over 5 minutes to run a mile. So it sounds like as he got older, he got faster. Alright, so let's see if we can figure out which one of these descriptions match that. So which statement best describes the relationship between Marvin's age and the time it takes him to run a mile? Alright, so as Marvin's age increases, the time it took him to run a mile increased. So remember, increase means get bigger. So or longer, in this case, because it's time. So did it take him longer to run a mile as he got older? No, we already said it took him less time. So as Marvin's age increased, the time it took him to run a mile decreased. Decrease means go down. Alright, that sounds like it, but let's just check our other choices just to make sure. For C, as Marvin's age increased, the time it took him to run a mile remains constant. That means it stayed the same. Well, if I look at this line, it didn't stay the same. He definitely got faster. So I wouldn't say constant. And then D, I should say, no relationship between Marvin's age and the time it took him to run a mile. Now, I'm going to fix mine right now. And I'm going to fix yours before I even send it out to you. So there's no relationship between Marvin's age and the time it took him to run a mile. All right, well, do you remember what no relationship looks like? Come back here. Here's no relationship right here. So it's not all spread out everywhere. It definitely looks more like a negative trend, where it says as one increases, the other decreases. All right, so which choice was that? That's right, that was B. So I'm just going to highlight that. And I'm just going to, let's see, can I just highlight? Ooh, let's see. There we go. Now I'm just going to highlight it in yellow. That's our answer. All right, let's go to the next slide and try that one out. Which scatter plot shows data with a negative relationship? All right, take a look. See if you can take a guess. Which one do you think it is? Yeah, you're right. It's D. So A shows a no relationship. B shows positive. C shows that constant relationship. And that's what we saw in that previous problem. This one shows a constant relationship. D shows a negative. All right, so how can we do that? Let's see, I can get a shape. And can I circle it? Let's see what happens if I try to circle this. Ah, it covers it. All right, let's do this. Can we, let's see, let's format that shape. And we can do, no, it won't let us. Sometimes you can change how, like if you can see through it. I don't see that available on here. Alright, so now I'm going to delete that. Okay, so we can't circle it, but what we can do is, let's see. Maybe I can recover it. Let's see. Maybe I can do that. Oh, that kind of highlights it. That works, right? And that'll highlight it. Shows us that's our answer. I like that. Alright, let's go to the next slide. Example 4. Which of these best describes the relationship of the data shown in the scatter plot? Alright, so take a look at it. What's happening with those points? Do you see any kind of pattern? I'll give you a second to see if you can take a guess. Alright, so what did you guys pick? I'm going to go with no relationship. What do you guys think? Is that what you guys picked? That seems to make the most sense to me. So I'm going to close out that thing to the side. I'm going to highlight. And I'm going to highlight in yellow, since that seems to be our thing. So no relationship. Alright, and then we can come down here. And let's take a look at this. I know this is kind of small. We're going to do the best that we can. So this scatter plot shows the average price of a gallon of gas during each month in 2013. Which statement best describes the gas prices as the months progress from January to December? Alright, so from January to December, what's going on here? We start all the way up here in January at $3.70 for a gallon of gas. By December, looks like they kind of stay the same. They kind of bounced around, went down, went up, went down, went up, went down, went up, went down, 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 and then up a little bit. So I would say, in general, it's like the trended down, right? Kind of a negative trend. So over the course of time, looks like the gas prices end up going down. All right, let's see which one of these answer choices matches. So the graph shows a positive relationship for the average price of a gallon of gas. Well, if it's going down, is that positive? No, it's not. The graph shows a negative relationship for the average price of a gallon of gas. And that's probably what I would go with, negative. Because in general, it is going down. All right, but let's just check our other choices. The graph shows the average price of a gallon of gas remains constant. Remember the one example we saw of constant had the line going straight across, a perfectly horizontal line. So that's not this at all. We definitely trend down. And then D, the graph shows no relationship between the average price of a gallon of gas and the months. Well, it does seem a little scattered up this way, but then we do see a definite drop down. So I would go with B. Alright, so I'm going to highlight that. Okay, so that is our notes. I hope you guys like doing it on the PowerPoint slides. Hopefully that makes it a little bit easier for you guys. You will be able to access this through Google Classroom. And I'm going to try and do this again next week if you like it. Alright, make sure you give me some feedback on how you like the notes in the PowerPoint slides. And I will see you guys in class soon. Bye!